Hi, this is Dilma da Silva, and I am here trying to address a question that I had from many students during virtual office hours. So today is Sunday, your homework 6 is due tonight, and it seems that many of you are having a difficulty understanding how to approach a problem to give a recursive solution. So that means that many of you know how to do a non-recursive solution. So some people say, okay, if you give me a word, kayaki, as a string that I know using, for example, variables I and j that I keep going. I compare k with k, then I go to the next I and the next j, and I know how to determine if it's palindrome or not. And some of you showed me your code and you know how to do that. But the thing is, that's not what we are asking. We're asking you to learn to think recursively. So the idea here is to get used to a new technique of solving problems that involves a recursion. What is that? That means that you have a problem of a size n. What does that mean? Either you have an array, a vector, whatever you want of any elements that starts from 0 to n plus 1, or you have a string, which you may remember, a string is actually a vector of characters that you can address position at 0 and the last one position, length minus 1, and that works, okay? So this is the size of the problem. So do you have a problem of size n? If someone magically gave you a solution for a smaller problems, so you have a colleague or me, I tell you, I can give you the routine that will solve a palindrome for a smaller problem. Can you then now derive a solution for the whole thing? So let's think about it. A smaller problem, okay, palindromes, they go like this, and the size here, the size of the problem is 9. What do I do? Well, I know how to look at the extremes. If the extremes are the same, it will be a palindrome if the whole thing here is also the same. So that's the smallest problem, okay? So you look at the problem of determining that an arbitrarily large string is a palindrome by saying, I can just check the extremities, and if they are equal, then it will be a palindrome based on what happens for the internal one, the smaller one that I'm assuming I know how to solve. Okay, what if people give me this? Is this a palindrome? Well, I know how to look at the extremes, and therefore I look, A is not equal to F, and I can just return, not palindrome. Okay? If they were equal, then I was going to invoke recursively to check on that piece. So that's what you have to do. Attack the problem thinking, if I had a solution for an internal part, what would mean the external part, okay? And you always have to remember that when you are trying to build this, I have a solution, ideally, the problem gets to be so small that it's very easy to do. So you start with this big one, and then to solve like this, you can recursively just look at the extremes, and you keep reducing until you have something small, like just 1. Or if we are checking this string here, I will check A and A. When I try to check a smaller one, it has only 2, I can just compare and I'll be fine, right? It works because it's an even number, okay? So that's the thinking. So let me do an example with you, okay? Let's say that I ask you to write a function, fat, that computes I want to fact to compute the factorial of n. Okay, and then we remember from high school, which for me it is 35 years ago or so. But for you, high school was that recent, and you remember that was something like this. So if you look at the definition of factorial, it is the kind of solution that, if I had the solution for factorial of n plus 1, I know how to build the one for the bigger problem, n, because it is n multiplied by factorial of n. I'm sorry, so let me do this. Factorial of n minus 1. Okay, so that's what I want to write. So I want to say my function returns an integer. The name of my function is fac, and it receives an integer. And how I want to do it? Let me think about it. I need more space, so let me get this piece here. Let me cut it. I want to move it down to the next page, if I can, if it lets me. Oh, it didn't let me. Okay, it didn't work. I'll write it again. So I was writing the code. The code is the name of the function. It's factorial, whatever, fac. It gets the parameter n. It's an integer. Okay, and I want to resolve it in terms of returning the result in terms of past results. So I want to say that the solution, and I'm returning the solution, is n multiplied by the solution for n minus 1. That's what I want to write. But the trick is with recursion is that you need a base for the recursion. If you keep going n minus 1, the computer will keep going, let's say factorial of 4. It will be 4 and then try to compute fac of 3, which will ask for fac of 2, fac of 1, fac of 0, fac of minus 1. Doesn't make any sense, right? The computer will blindly keep doing this forever. So you need the base of the recursion. You need to make sure that at some point you know that the problem became so smaller that you know the solution. So what is that? Well, which is a small problem? When n is 2, you know that or 1, the factorial of 1 is 1, right? So I can do if n equals 1, return 1, else return n multiplied by fac n minus 1. And that works, okay? You may be wondering, why did I go to all the way to 1 instead of doing 2 and then just returning factorial of 2. The reason I did that is my program may need to return an answer for 1. So because 1 may be a valid answer, then I need to do this. So I hope this has been helpful, and I'll be posting it right now. Thank you.